we present HoloChemie, a sustainable fabrication method for soft biochemical holographic devices used for ubiquitous sensing. For example, sensing biomarkers like glucose and lactate in sweat. Extreme pH sensing. Here we demonstrate sensing acidic pH. Alternatively, we can sense extreme alkaline pH, which is usually found in polluted soil. We can also sense carbon dioxide emissions from an SLA printer in a makerspace. We use the biochemical properties of living matter for sensing. When light is incident on a substrate material, it absorbs light of certain wavelengths. In contact with an assay made of these biomaterials, there is a change in absorption of light across the UV visible spectrum. To implement this sensing, we created custom hardware consisting of LDR and LED arrays for real-time sensing. The glucose detection assay. We use glucose oxidase derived from Aspergillus niger as the main material for creating this assay. The assay is prepared by first adding a few drops of phosphate buffer saline solution to some starch, then add some potassium iodide. It is then mixed with glucose oxidase to create the final assay. Mix thoroughly, but gently, to avoid damaging the enzyme. Lactate detection assay. We use lactate oxidase derived from Aerococcus viridans bacteria. First, combine the potassium iodide and starch in a phosphate buffer saline solution as before. Then add the lactate oxidase to the solution. And mix gently and thoroughly. Hibiscus tea assay for highly basic pH. Add commercially available hibiscus tea to distilled water and mix it well. Boil it for 15 to 20 minutes. This is just making hibiscus tea. Then filter the tea and use as an assay for alkaline pH sensing. Bromothymol blue assay for highly acidic pH and carbon dioxide. We prepared this solution by dissolving bromothymol blue powder in 0.01 normal sodium hydroxide. Once the assays are prepared, they can be brushed, sprayed, and drop casted onto the substrate to create a patch. These results from our user study show that our biosensors work on the skin. Spectrophotometry analysis shows that our sensors have a response in both the visible and UV spectrum and show clear colorimetric results. Live fatigue prediction for VR exercise. While exercising, a VR display shows the current LDR intensity within the device, corresponding to the colorimetric change of the lactate patch. Using our holographic sensor, the user's fatigue point is predicted based on their sweat lactate, and they are reminded to take a break. Sweat glucose monitoring app. A user-friendly UI for checking your sweat glucose.